Okay, on the previous video, we discussed about the fixed bias configuration. So take note of this one. This is our fixed bias configuration. So if we set the resistor in the base, which is RB, into a fixed value, the tendency is that your current IB will also be constant. However, despite the fact that you have a constant value of current at your input, which would influence the value of your current IC, still the operating point or our Q point will still be not stable or unstable. So one of the way in order to stabilize the circuit or stabilize our operating and Q point is to add a resistor on our emitter. So this will be the so this is our goal, or this is the circuit that we are going to implement. So we have a resistor at the emitter side. So take note also that we have the same parameters here. So we could possibly create or connect this one into our VCC having the same source. So we have a source which is VCC. But we could redraw the circuit to look this one. Still, this could be VCC. So let's try to solve our circuit. So basing on the circuit nga ra sa inyong module kay para mas may reference ka mo when solving with the circuit. So we have this one. So take note that whatever type of circuit, whatever type of biasing are we discussing, so same process will be used. So we are going to analyze and form the equation using KVL or Kirchhoff's voltage law. So then we are going to use the relationship between IC and IB, which is IC is equals to beta IB. Then we are going to use that into another loop in the outside loop, which is your current to emitter nga loop. And then either you are going to substitute the value of your IE, which is beta plus 1 IB, or you are going to have the assume that your IE is approximately equal to IC. So let's try to solve this one. Okay, so we are going to analyze the loop nga ara sa aton nga or sang aton nga input nga loop. So we are going to start. Okay, ang mga parameters sa ating input na loops are the following. So we have your VCC, IB, RB, we have your VBE, and we have your RE. So let's start our solving. Okay, so let's start this one. We have so the direction of your current or of our current is from this one to this one. So the last ang last nga naagyan niya nga value is plus. So our symbol is positive. So we have positive nga VCC minus. Maagi siya sa imong RB which is IB RB. So minus ang aton nga VBE. So minus VBE, then minus IE RE. Equals 0. So here, pwede naton makuha ang values ng aton nga IB. Take note of the relationship of your IB and IE, which is IE is equals to beta plus 1 IB. So we are going to substitute this value sa ating nga equation, making it VCC minus IBRB minus VBE minus beta plus 1 IB RE is equal to 0. So now we are going to combine sa ating nga IB. So we have VCC minus IBRB minus beta plus 1 IBRE minus VBE is equal to 0. Then, pwede naton i-transfer ang aton nga value nga may IB into the right side of the equation, making it, or pwede naman lang nga siya. So, we will have, okay, so diretsyon na lang ta, we have VCC minus VBE. VCE minus VBE is equals to IB RB minus beta plus 1 RE. Okay, so beta plus 1 RE. Next, okay, so minus this will be plus. So we have, if we find the value or the formula for in finding the IB, that will be IB is equal to VCC minus VBE all over your this one, which is RB plus beta plus 1 RE. So that now will be our formula in finding the IB of the equation. Now our next goal is output nga side. So the output side will be dependent sa dere natin nga value. So we'll have, so diretsyon na lang kita dere, we will have VCC para sa output side, VCC minus IC RC minus VCE minus IE RE is equal to 0. So take note that your IE is approximately equal to IC. So we are going to substitute this value. We will have VCC minus ICRC minus VCE minus ICRE is equal to 0. Then we could have the this one transpose nato ng aton nga IC sa right side of the equation, VCC minus VCE equals to ICRC plus ICRE is equal to 0. This will be VCC plus VCE is equal to IC, factor out na lang. So we will have RE plus RC. So, ang value gali sa ato nga IC will be VCC minus VCE all over RC or RE plus RC. So that now will be the equation para sa aton nga, sa mga parameters nga IC kag RE. So take note lang of the relationship nga gingamit naton for the on solving for the parameters nga kinahanglan naton mabalaan. Okay, so now we are going to apply sa aton nga gintunan about emitter bias configuration and solving a certain circuit. So take note nga sa diri sa aton circuit nga i-solve subong, you have to consider nga hindi parehas ang voltage nga ginagamit naton. So it does not matter man sa process nga himuon naton, only that make sure nga ang substitute ni mga value for your input and output are different types of voltages. Para sa input nimo 10 volts, para sa output nimo 12 volts. So take note lang, be mindful if you are solving for certain circuits. But still, the same siya po ng process, analyze the input and then relate it sa imong nga output nga circuit or sa output nga loop. So let's start our solving sa aton nga input. So we will have, start kita with your 10 volts. So we will have 10 volts minus, okay, minus kita sang 400 kilo ohm times ang aton nga IB, which is ang mo ang aton ginapangita. So minus, okay, the voltage along the base and emitter, which is diode lang man, which is 0 minus 0. Okay, so minus 0.7 volts. Then minus sang para dere, which is IE RE. So take note of the relationship of your IE in relationship to IB. IE is equal to beta plus 1 IB. So diretso ta na lang, beta plus 1 is 100 plus 1, so that will be minus 101. Then IB naton nga ginapangita is equal to 0. So, in order to find the IB, so pwede ito siya transpose sa right side of the equation para masapos sa aton. We will have 10 volts minus 0.7 volts is equal to, so maging positive na siya, IB times 400K plus 101. Okay, so take note nga may ara, pag kita gali resistor nga wala na butang dari, multiply kita by 1 kilo. So we will have plus 101 times 1 kilo. So now we could find the value of your IB. We will have IB naton will be 10 volts minus 0.7 volts all over 400K plus 100 times 1K. So let us try to solve this gamit ang aton nga mga calculator. So we will have okay, we will have sang value nga 10 minus 0. Okay, 10 minus 0.7 all over 400K plus 100 times 1K. 10 volts minus, so 400K plus 100 sa latin copy, this will be 101. So aton answer will also be dependent sa value nga 101. So we will have the answer 1.856 times 10 raised to negative 5. 1.856 times 10 raised to negative 5. Or if we are going to transform this into engineering notation, this will be 18.56 microampere. This is equal to 18.56 microampere. Okay? Now we are going to have sang aton nga output nga side. So take note of the relationship sa imong output nga side. So you have to relate sang IC kag IB. Your IC is equals to beta IB. So to find the value of your IC, this will be equal to beta naton nga 100 multiplied by IB, which is 18.56 microampere. The value of our IC will be times 100. This is equal to 1.856 times 10 to negative 3, or 1.856 milliampere. 1.856 milliampere. So this will be the value of our collector current. So now, pwede na natin makuha ang aton nga value sa aton nga VCE. So for your VCE, we'll have ang aton nga formula is VCC. So kung natawon naton sa aton nga circuit analysis, so we'll have VCE or VCC is equal to same ang value nga ma-flow diri, assuming IC is approximately equal to IE. So amo naton consideration diri. So we will have VCC minus KIC RC minus VCE minus ICRE is equal to 0. So find the value of your IC, that will be VCC. Okay, so ang pangitawon tagali is VCE nga values and that IC. So we have may value na tasang sang IC diri. So VCE is equal to VCC minus factor out lang IC. Then we have RC plus RE. Okay, so substitute kita values. So VC 12 volts ang atong nga VCC minus IC naton is 1.856 milliampere times RC naton nga value is 2 kilo ohms. So 2 kilo plus RE naton is 1 kilo ohm. So we will have 12 minus 1.856 milliampere times 3 kilo ohm. So this will be 12 minus 1.856 milli times 3 kilo ohm. So aton answer will be 6.432 volts. So 6.432 volts para sa aton nga VCE. So pwede na siya naton ma-plot into sa certain naton nga circuit or sa certain naton nga graph in order to find a load line or para makita naton ang aton nga operating point. So pwede gid nga himuon na Japon. So but I am trying to present here kung ano ang possible nga itsura or possible nga way in order to solve a circuit. So same lang na Japon despite any type of circuit. Analyze the input nga loop gamit ang Kirchhoff's voltage law. Relate it sa mga output using the relationship IC is equal to beta IB. Approximately IE is approximately equal to IC. Then take note also of the relationship of your IB kag IE. IB is equals to beta plus 1 IB. So amo lang man ang mag-solve kita sa certain nga circuit. Okay, so take note, if we are going to have the formula para sa ating nga IB. So that will be equal to um, so ang formula naton sa IB generalize naton. So formula for our IB is equal to okay, IB naton is equal to um, okay, balikan natin sa babaw. IB is equals to VB or VCC minus okay. So that will be VCC minus VBE all over kay duwa ka value RB plus beta plus 1 RE. So this will be RB plus beta plus 1 RE. So this is the formula for your IB. How about if we have the value of IC? So IC naman is, so that is beta IB. So pwede lang nga beta multiplied mo sa kabilugan nga formula which is VCC minus VBE all over RB plus beta plus 1 RE. Okay, so we are going to have a simple lang nga analysis of the formula. So what will happen kung ang value sa akong nga RB is very small. Gamay-gamay lang gid siya. So buot silingon this will not affect my circuit. So pwede the tendency is that pwede na makancel ang akong nga value approximately equal na ang akong nga beta kag ang beta plus 1. So, pwede na makancel. So, that means gali nga kung ang imong RB is very small relative sa sini nga value nga beta plus 1 plus beta plus 1 RE. So, pwede that your circuit will not be affected by the value of beta. So, this is considering the relationship nga RB should be much smaller compared sa beta plus 1 RE. So, pwede nang aton din yung answer will be not dependent na sa sina nga value dayon. So, considering dapat ng imo RB should be 0.01 sa aton nga beta plus 1 RE. Okay, so mo ng consideration, possible yung consideration. So, take note pag lang of if, for example, in a certain circuit, kinapamangkot kasang value of the relationship of your IC and IE. So, anong relationship of IC and IE? Based on the discussions nga sa previous nga discussion, you have a relationship nga nag-relate sa IC kag IE, that is alpha. So the value of alpha is IC all over IE. So base may ara lang da sang maka base may mapamangkot daw may ma-encounter ka mo sa certain yung mga circuits. Or pwedeng himuon mo siya IC is equals to alpha IE. Okay? So take note man of the relationship of your alpha. Ang relationship sang alpha sa imo nga beta. So alpha to beta is beta over beta plus 1. So take note of these equations. So pwede nga ari mo tandaan kag pwede man ari mo nga tandaan. Okay, so base lang kita, balik kita diri sa circuit. For example, same lang nga circuit. So pamangkot bisay mo what is the value of your, so for example, mahaba ko, mayari ko di point, dari ko ma-measure. So pila subong ang value of my VE. Pila ang value sa akong nga VE. So let's erase para mas maintindihan naton. So kung amo na ang gitpamangkot sa circuit, pila ang value of your V. Okay, same simple lang no ang iyang pamangkot. If you are going to solve for the as amo lang na certain amount. So ang ginpamangkot niya pila ang value of your VE. So if amo ni ang imo nga ginapamangkot, this is relative to ground. Relative sa diri nga point. So diri hasta dira. Pila na nga value. So syempre amo lang na yung consider naton sa diri lang nga part. So, ano na din ang ari dari? So, that is IE, RE. So, IE, RE lang. Kaya mo lang nang pamangkot niya. So, solve ka na dayon based sa imo value nga IE, RE. Kung mayara ka na value of your IE. So, next, what if, kung ang ginpamangkot sa imo is the ring apart? VB, for example. VB. So, let's name this VB. So, VB siya. VB. Take note that is still relative sa aton nga ground. So, erase natin para mas maintindihan kag mas klaro. So, in order to find the value of your VB. So, this is relative sa ground. Halin dere pakadto sa ground. So, same man Japon. That will be, so anong ginagyan niya? So, that is VBE minus IE RE. So same lang. Halin dari, pakadto dari. Okay, another relationship nga gusto ko i-point out is the value of your VBE. Okay, para sa VBE, VBE, this is equal to VB minus VE. Okay, so take note also of this simple lang analysis. Same man siya if you have VCE. Yung ginapamangkot sa imong VCE, that will be VC minus VE. So, take note lang of the analysis, simple lang nga analogy or simple nga circuit analysis para sa transistor circuit. So, this is it for now. Thank you everyone. Stay safe and please study your lessons.